Hi, good day. I hope you're having a nice time at the conference. This is me, Kritika, and I worked with Professor Thomas on this paper, which we published in Innovation in Language Learning International Conference. As you can see, the paper is titled An Ensemble Classifier for Error Detection and Recommendation in the Use of Articles by the Learner's English. Basically, it focuses on automated evaluation of learners' English and with a special focus on the article microsystem of the English language. To a much more deeper description of our research question, we wanted to understand how machine learning can help solve or correct English grammar errors, especially with learners. In today's world, there are many people trying to learn English as a second language in order to communicate with their peers. So as the number of learners increases, it's difficult for the evaluators to give them feedback as soon as possible, and there's a longer waiting time before a learner receives feedback, and it's also too tedious on the evaluators itself. So we try to build a machine learning based error correction and detection and correction approach, where the outcome of the machine learning system is actually the correction to an error which a learner has made. The focus of this paper is the articles microsystem, which is the, and zero articles in the English language. As an overall structure, we would first look at a basic introduction to what our problem and what our solution looks like, and a bit of a theoretical background of the articles and the system we've proposed. Later, we'll discuss the results we encountered, and then at the end we talk about our future work. As we spoke earlier, the focus of this paper is on the articles, the, and null. These are fundamental elements of the English language. They are found before a noun, which is they qualify a noun. And these are most commonly misunderstood by learners. For example, if you look here, it says he drank a water, where water is a noun, and if you in correct English, it just says it'll just read he drank water, and the article is not supposed to be there, and that's the error. And the next example, if you see, she saw car. Car here is a noun, and we would expect either a or the as an article qualifying the noun, and here the article is actually being missed. So these are some of the mistakes which a learner would do. And so as from a machine learning standpoint, if we have to automate this error detection and correction flow, we need to understand the noun, the quality of the noun, and the surroundings of the noun itself in order to determine what the article should be. As we said earlier, the machine learning system learns these as features, and the outcome of this machine learning system is actually the correction to the error which is being made. These are the three articles in the article microsystem, the, and zero article. The zero article is practically not having any article before the noun itself. Is a singular article, and it's also used when the noun's being freshly introduced. For example, she saw a car, and she saw a book, and etc. Where car is a singular noun, and book is also a singular noun. The article the is used when the nouns have prior or posterior references, or when the nouns have been introduced in the past, or it's going to be introduced in the future. For example, she had a car, the vehicle was punctured, which means here she's clearly referring to the car which she mentioned in the previous sentence. Zero article, as I said, it's not having an article before the noun. It's usually found before uncountable and plural nouns. We'll talk about countable and uncountable in future slides, but here, for example, it's water, which is uncountable, and pens, which are plural nouns, plural countable nouns. In order to train the machine learning system to understand the concept of articles, it needs basic corpora, or which is written by native speakers. So the idea is to understand native usages of the articles and apply the understanding to help correct non-native English writings. So here we need a native corpus, and in our case it's the Brown corpus, which has 15 genres and American written English, and it has almost 1 million words. And the machine learning system understands the article usage written by writings in this corpus, and then apply the knowledge on the Ryelek corpus, which is the Russian learner corpus, written by which are essentially essays written by Russian speakers of English. and it has around 0.8 million words in it. And the errors which are made by the learners are marked and classified as the kind of errors. For example, if the user has made errors in the articles or errors in the modal verbs and etc., and the corresponding corrections have also been given by a human evaluator, which helps test the efficiency of our machine learning system. Texts are a large collection of words, and it's practically impossible for the machine learning system to understand each and every word we speak. So, for simplicity, we reduce these texts as features, and the below are the 4 features which we would be using to accomplish this article error correction task. The first one is the post tag, which is from the Pentry Bank text. It will help us identify or classify every word as a noun or a verb or an adjective, etc. The second was named entities. For example, a noun can be a proper noun, and internally it can represent a location or a person's name or for example, a company's name and things like that. So a named entity recognition would actually add more details to a named noun or a proper noun. And even sometimes it helps us classify things like yesterday and today are actually timed units than any other forms of noun. So the third one is countability. We'll see more about it in the next slide. And the fourth one is Anaphora. The countability of the noun is very crucial in determining the article form. For example, the usage of a and the zero article is determined by whether or not the noun is countable and uncountable. For examples of countable nouns are car, pen, book, etc. An uncountable noun is things like water, air, lake, and stuff. So in this table, if you can see, car, pen, and country are countable singular nouns which trigger the use of a. And phones and chairs are countable plural nouns which would trigger the usage of the zero articles or the null article. And things like water and air is uncountable again, so we would not ideally put an article before it. So in order to determine that, we used something called the Google Ngram service, where we presented the service with 2 bigrams, which is many followed by the noun. For example, many water and much water. So if it's a countable noun, the chances are that we use it with the word many before it. And if the noun is uncountable, we are going to say much followed by the noun. For example, we would always ask how many cars do you have than how much cars do you have. And we'll ask how much water do you need, but not how many water do you need. So we leverage this concept to identify if a noun is countable or uncountable. We got the frequencies from the Ngram service of these bigrams, and the one which had the maximum frequency. For example, if the word's constantly found next to the word many, more than it's been found next to much, it means that the word is countable. If not, it's uncountable. As you may recall, initially we had said the articles the is used when the noun there's a reference to the noun prior or post the usage of the noun itself. So the presence of context around the noun or usages of the noun in the previous and posterior places triggers the use of the. So these are called anaphora and cataphora links. Cataphora is when the noun, the reference of the noun occurs after the usage, and anaphora is when it occurs before the usage. So here, we only look at anaphora, which is the presence of introduction of the noun. And it, as I said, it triggers the use of the article the. For example, she saw a blue Ford parked by the street. The car was punctured. The blue Ford is the car which got punctured is the reference here. So which triggers the use of the next to the word car. So in order to accomplish that, in the NLP package, there's something called the word net in Python, which we use to understand similar frames and synonyms of the noun which can be found around it. And these are not just synonyms of the noun. We also have adjectives and other adverbs which are most commonly found next to the noun, which helps understand the references of the noun. Once we identify such a reference, we mark that the noun is a noun with some context, and feed it to the machine learning system, hoping that it can trigger, hoping that the machine learning system would ask us to use the article the next to it. As I said earlier, we use the brown corpus, the native speaking corpus, for training, and in order to evaluate the performance, we use the learner's corpus. So the idea is that the machine learning system will understand how the native speaker speaks, and it helps evaluate how a student would speak, just like the reality scenario where the evaluator is a native speaker and what he evaluates is a learner's English. So the training data set here is from the brown corpus. And if you can see, the first usage is the word opponents. It's a plural countable noun. So there's no article before it, which is the zero article. And the second one is similar proposal, where proposal is the noun and it's countable, so it has the article a. The third one is election. In the sentence, there was reference to the word election. So if you look at the feature, it's NN plus CNT plus CXT, which is noun, countable, and with context. So the article is the, and similarly so on. Once the system is trained on the brown corpus, it now has successfully learned the article microsystem from the examples presented. So we use this knowledge on the testing data set, which is also the gold standard data set. It has a combination of correct usages and incorrect usages. The reason why we had this is because the system we wanted to test the error detection quality, which means if the system is able to say if a usage is right or wrong. And secondly, we wanted it to test the error correction efficiency, where the outcome from the machine learning system is the correction to the usage itself. So in this table, you see the text followed by the feature of the text and the error in the text and the expected outcome. A bit of a background about the machine learning algorithms which are being used here. Ideally, these are text classification tasks where the inputs are text features, and the outcome is or the label is the text usage which we expect, or in our case, it's the articles which are the corrected errors. So we use something called an ensemble, a majority voting ensemble, where we use 3 machine learning algorithms, and we also we pick the majority of the outcomes suggested by these 3 algorithms. For example, the SVM is one text classification algorithm, which when run on a particular set of features would give a set of outcomes. Similarly, the naive Bayesian and the maximum entropy. So 2 out of 3 of the outcomes is what we pick as the final outcome of the text classification. On the experiments we conducted with the machine learning setup and the data sets, we had 2 sets of experiments. One was the error detection efficiency, and the other one is the error correction efficiency. The first confusion matrix which we see here is an experiment for error detection efficiency, where when presented with the feature, we actually test if the system is able to rightly classify if the usage is correct or wrong. So we had for this experiment we had 5,000 data tuples, where 2,500 of those were incorrect and the rest were correct. So from the confusion matrix, we can see that 2,000 out of 2,500 correct instances, 2,125 were marked correct, and out of 2,500 incorrect instances, 1,750 were marked incorrect. So that determines the error detection efficiency. And the second confusion matrix is the error correction efficiency, where if the system says that, let's say for this particular feature, is the expected article, is the predicted article, does it match the expected outcome, where the expectation is set by the human evaluator in the RELEC corpus. So this helps us evaluate if the system can be a good evaluator of the articles. So if you look at the first row here, out of this experiment actually had almost 10,000 records, where it was almost equally split between the 3 classes. So you can expect 3,500 rows in each outcome. So 2,396 of the features which expected A were also predicted as A. And if you see, the majority of misclassification has happened at the 0 article, where when a feature expected the machine learning system said it should be a 0 article. And similarly for the other cases here. We use the following measures to quantify our efficiency of the system: accuracy, precision, recall, and F1 score, where the accuracy measures the classification correctness of the system. We got an accuracy of 70.4%, and a recall of 66%, a precision of 68%, and an F1 score of 67%. As an end to this presentation, there were a bunch of observations which we saw from a learner corpus. For example, if the noun itself is misspelled, the chances are that the post tagging itself would not work well because the noun is not recognizable to the Pentry bank. And so how do we deal with some of the misspelled errors? And also misplaced nouns, like for example, when the user wanted to say a noun, let's say school, he would use a different noun itself of things like an institution or something. And how does such misplaced nouns change the behavior of the understanding of the system? And also, as we can see, our accuracy is 70%, and in future we would like to identify more features which will help the system understand the article microsystem more precisely and give us good results. Thank you.